Okay, so today we're going to do lesson 4.4, proving triangle congruence. So it says SSS, that stands for side, 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 and SAS stands for side, angle, side. So we know that if all corresponding angles and all the corresponding sides are congruent in two triangles, then the triangles are congruent to each other. In the next two sections, we're going to find other, basically shorter ways to prove triangles congruent. The first one is a postulate. So this is the side, side, side congruence, abbreviated with SSS. This says if the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. So that means all three. So if you have all sides of one triangle congruent to the sides of a second triangle, then the triangles are congruent. That's our conclusion. So we see a picture here, two triangles, and we can see each pair of corresponding sides are congruent. So in other words, we don't need to know anything about the angle measures here. We know nothing about the angle measures. We only know the sides are congruent. So what we want to do is we want to write a congruent statement. And a congruent statement is listing the triangles in the correct order. So it doesn't matter how you name the first one. So let's say I go with GHI. This is going to be congruent to the other triangle, but it's very important that we make sure that the letters go in the correct order. So if we go GHI, then we are going from the side that has 2 marks through 1 mark through 3 marks. So we want to go in that same order. So we're going to go J, K, and then L. So this is our congruent statement regarding the two triangles. And we can also just make sure, like for example, if we look at the first two letters GH, that should match up with the first two letters here, JK. And they both have 2 markings, that's good. HI, the last 2 letters, has to match up with the last 2 letters of the other triangle, KL. So HI and KL both have 1 tick mark. And then we can also double check the first and the last letter, so GI should match up with JL. So GI and JL, both have 3 tick marks. So we know that we have everything in the correct order. So we're going to complete the following proof. And this is what we know so far. So we know GH is congruent to KJ. We know HL is congruent to JL. And we also know L is the midpoint of GK. All of these are the provided given statements. Now, since we're trying to we want to prove the two triangles congruent, we could go through the process, or we could try to go through the process of proving all 3 sides and all 3 angles are congruent, but we don't have any information about the angles. So we're actually going to try to get these to be congruent. We're going to try to prove this by side, side, side congruence. So we want to get all 3 sides. Now, as I look at the given statements, we have GH and KJ. That's already 1 pair of sides. So I'm just going to put an S there next to it. You actually don't need that as part of the proof. I'm just going to put that in kind of so you can see, you know, as we go step by step, what the missing pieces are. So the next step is HL is congruent to JL. That's another pair of sides in our triangles. So we really just need 1 more pair of sides. We need to try to get GL congruent to LK, and then we have side, side, side. So if we look at the other part of the given statement, it says L is the midpoint of GK. So here's GK. If L is the midpoint, what does that tell us about the 2 segments that make up GK? That tells us that they have to also be congruent. So I know GL is going to be congruent to LK. So I'm going to write that down as my next statement. And actually that's my third pair of sides, but we need a reason. So the reason, again, remember how I said always kind of go back and look at the information that is given. Look at the vocabulary that is used. It says here it's the midpoint. So that basically leaves us with two choices. We have definition of midpoint or midpoint theorem. Midpoint theorem tells us that the segments are congruent, whereas the definition of midpoint tells us that the measures are equal. Since we went with congruent, we're going to use midpoint theorem for this one. Now we could have used definition of midpoint and then we just have to use an extra statement to say they're congruent by definition of congruent segments, but this is a much shorter process. So actually we're finished. We have the three sides are congruent, three pairs of sides, so we know triangle GHL is congruent to triangle KJL, and our reason is side, side, side. Example 2, we want to determine whether RTZ is congruent to triangle JKL. So we have a set of coordinates here, so let's go ahead and plot them. So R is 2, 5, so here's R. Z is 1, 1. We have T is 5, 2. So here's triangle RTZ. We want to compare that to JKL, so L is at -3, 0, so here's L. K is -7, 1, so there's K. And J is at -4, -4, so right here. So we want to determine if these two triangles are congruent. We're going to try to find that by side, side, side. So if we can check the measures of each of their sides, we can compare them and see if they're congruent. And because these are not just horizontal or vertical distances from each other, we actually are going to have to use the distance formula. And yes, it's a little bit of a lengthy process because we have to use the distance formula 6 times. So we're going to start with, you can start with any side. Let's say we start with RT. So RT is going to be the square root. We have 5 minus 2 squared plus 2 minus 5 squared. So we actually get 3 squared plus -3 squared, which will be 9 plus 9, square root of 18, which is 3 root 2. So I know this side is 3 root 2. What I'm going to do is I'm actually going to jump to the other triangle, because if I can rule out, a pair of sides that aren't congruent, then I don't need to keep going. I don't have to use the distance formula over and over again. So if I look at RT, or the first 2 letters, that should match up with JK. So I'm going to check segment JK and see what that measure is going to be. So we have the square root. So JK is going to be -4 minus -7 squared plus, and then we have 4 minus 1 squared. Well, 4 minus -7, that's going to give us 3. -4 minus -7 is 3 squared. So we have 9, and then 4 minus 1, that's 3 again, squared. So we actually get 3 root 2 for segment JK. Okay, so far we know these 2 segments are congruent. Next, I'm going to check, so we checked the first 2 letters. Now we're going to go with, let's go with TZ. So TZ, we have 5 minus 1 squared plus 2 minus 1 squared. So we get 4 squared plus 1 squared. So that's going to be square root of 17, which doesn't reduce. So TZ is square root of 17. So TZ was the last 2 letters, so we're going to see if that matches up with KL. So KL is going to be -7 minus -3 squared plus 1 minus 0 squared. Here, these are going to end up being added together. So we get -4 squared is 16 plus 1, so we have square root of 17. So KL is the square root of 17. So these 2 segments are congruent. All right, we're going to check our last 2 sides. So we're going to check RZ. So RZ is the square root. So we have 1 minus 2 squared plus 1 minus 5 squared. So that's going to be a -1 squared, so that's 1. -4 squared, so that's 16. So we actually get square root of 17 again. So square root of 17 is here. And now we just really need to check JL. That's the last segment that we need to check for. And so JL is going to be -4 minus -3 squared, and then 4 minus 0 squared. So this is going to give us a -1 squared, so that's 1, plus 4 squared, 16. So we get square root of 17, which actually means that we have an isosceles triangle here, but they happen to be congruent. So we know triangle RTZ is congruent to triangle JKL, and just to show our reason is by side, side, side. We showed the 3 corresponding sides are congruent to each other. So we have one more postulate we're going to look at for today. It's called side angle side congruence, abbreviated with SAS. So this is going to say if 2 sides and the included angle of one triangle are congruent to the 2 sides and the included angle of a second triangle, then the triangles are congruent. Now, what we mean by the included angle, this is the angle that is created by the 2 congruent sides. So for example, if I look at here's GH and HI, where they come together, 95 degrees, that's the included angle. And so here if we look, here's LK. LK is here and JK is here. So where they intersect, that's the included angle. So that's 95 degrees. So when we're writing the congruent statement, like we did previously, we just want to make sure that we put them in the correct order. So if I go GHI, oops, need to put triangle in there. GHI, that has to be congruent to triangle JKL. Again, you can name the first one any way you want, but you just have to make sure it's the correct order. So GHI congruent to triangle JKL. Let's take a look at the following proof. And let's write down, what do we know? We know RQ is congruent to TS. And we know RQ, that's actually supposed to be a parallel statement. So RQ, change that to parallel. RQ is parallel to TS. And this is given. Now if I look at my picture, so here's RQ and here's TS. And I want to try to prove triangle QRT is congruent to STR. Knowing that, I already have a pair of sides that are congruent. Now I have 2 ways that I can try to prove these 2 triangles are congruent. I can try to do side angle side or side side side. I only have 1 pair of sides, and those happen to also be parallel to each other, but I don't have another pair of sides until I look a little closer, if you look at each of these triangles, so if I look at triangle R or QRT and I look at STR, notice they overlap. They actually share this side RT. So we're going to write that down as a congruent statement. We're going to say RT is congruent to RT. Basically, when we have two triangles where they share a side or an angle, we want to write that down. That's actually our reflexive property, if you remember that from our previous chapter. And that actually gives us a pair of sides that are congruent. Okay, so when we're proving by side, angle, side, or side, 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 we need to have each statement. So far, when we're looking at this, we have here's one congruent statement, two congruent. We need either an angle, an included angle, or we need a third side. Now, we don't have enough information about the side. We don't know about RS and QT. So let's take a look at our other given statement. RQ is parallel to TS. Well, if we have parallel lines, then we know corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, and consecutive interior angles are supplementary. So what we want to look for is a pair of those angles that will perhaps help us to prove the two triangles are congruent. And actually, alternate interior angles will be the one that will help here. This angle, angle QRT, is actually going to be congruent to angle STR. These are, again, if you're looking at these parallel lines here, RT happens to be our transversal. So if we're thinking RT is the transversal, we can see those two angles are congruent. And so my reason is this is the alternate interior angles theorem. And now when we look at our picture, do we have enough information? Yes, I have two sides and the included angle. I have two sides of the other triangle and the included angle. So this gave us another congruent statement, which is exactly what we needed. So we have triangle QRT is congruent to triangle STR, and our reason this time, instead of side, 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 it's side, angle, side. Again, the reason is we have two pairs of congruent sides and the included angle. Next, we want to take a look at just these pictures. Which postulate, side, 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 or side, angle, side, can be used to prove that the triangles are congruent if possible? So the first one here, part A, what do we notice? 1, 2, 3 congruent sides in each of them. So that's side, side, side. Next one, well, actually, if we look at this, this is an angle. This is another angle, right? And this is another angle. Angle, angle, angle is not a congruence postulate, so this is actually not possible. So we'll just put NP for not possible. For part C, we want to kind of look at, sometimes we can label additional pieces of information. So this is actually similar to the last proof in that they actually share a side right here. So when they share a side, we can mark that as a congruency. So looking at one triangle here, let's say this triangle, we have side, angle, side, and then does that match this triangle? Yes, we have side, angle, side. So that's our reason that those two triangles are going to be congruent. And then for part D, Okay, so we have two pairs of sides, and then they share that third side, so we actually have side, side, side congruence. Okay, we want to write a two-column proof. We have x is the midpoint of BD, and x is the midpoint of AC. And we are trying to prove triangle DXC. So let's take a look. DXC, that's here. We want to prove that's congruent to BXA. So that's this triangle. So let's write down the given. So x is the midpoint of BD, and x is the midpoint of AC. Now we used a theorem previously. Again, we look at this vocabulary. So right now we don't have any congruent statements. However, midpoint does what? Midpoint divides a segment into two congruent parts. So for number 2, let's use the first part. So if x is the midpoint of BD, so BD, that means BD is split into two congruent parts. So we know dx is congruent to xb. And our reason is midpoint theorem. The other given statement is x is the midpoint of AC. So here's AC, and these two segments will be congruent from the same reason. So I'm actually just going to list that. So AX is congruent to XC. Now, looking at our two triangles, we already have, here's one pair of sides, here's a second pair of sides, and that's all we can use from our given statement. So when we're done with all the information, we look back at our picture and see, is there anything else that we can identify? Well, they don't share any sides. However, you may recognize we have intersecting lines, and therefore we have vertical angles must be congruent. So I'm going to write down angle DXC congruent to angle AXB, and that reason is vertical angles theorem. And that gives me a pair of included angles. So if we, again, look back at our picture, and that's why it's helpful to label, we can see we have side, angle, side, side, angle, side. So statement 4 is our proof. So triangle DXC is congruent to triangle BXA, and our reason this time is side, angle, side. Okay, so our last theorem, or last proof, excuse me, we are given AB is congruent to CD, and we have AB is parallel to CD. So that's our given. Now, if you notice what we're trying to prove this time, it says AD is congruent to BC. So this looks a little different than the others in that we're not proving triangles congruent. However, we actually are going to try to prove the two triangles congruent in order to prove AD is congruent to BC. So you may remember the last lesson we had a corresponding parts of congruent triangles are congruent. CP, CTC. What this means is once we have the triangles congruent, any of their other corresponding parts will be congruent as well. So what we want to do is we want to get triangle, let's say ABD congruent to triangle CDB, if we can get those two triangles congruent first, then we can prove AD is congruent to BC by their corresponding parts. So take a look at what we have again. We have AB is congruent to CD. So that actually gives us a pair of sides. And AB is parallel to CD. So these are parallel. This looks similar to the first proof that we have done. Again, parallel lines, that's going to give us our alternate interior, alternate exterior, corresponding are all congruent. Consecutive interior are supplementary. The one that makes the most sense in this case is the alternate interior, just like we had previously. So we're going to write angle ABD congruent to angle CDB, and our reason is alternate interior angles theorem. That gives us a pair of pair of angles. And then we may notice both of these triangles share side BD. So I'm going to mark that as a congruency. So BD congruent to BD. Now, let's say you had BD congruent to BD and you listed that as statement 2 and had these reversed. That would be fine. Remember, sometimes we can list things in a little bit different order. Our reason here is reflexive property. And this gave us a pair of sides. So again, if we look at our congruence, our 3 congruent statements, we do have side angle side. So I'm going to write in here, triangle ABD is congruent to triangle CDB. And my reason is side angle side. And now, once we have that, any of their other corresponding parts, so AD has to be congruent to BC. So statement 5, AD congruent to BC. And this is CPCTC. Often, this is what these kind of proofs will look like. So if you're not proving triangles congruent, then, and you're given 2 triangles, chances are you're going to go through the process of making them congruent first, and then stating the other parts are congruent by CPCTC. Again, that's corresponding parts of congruent triangles are congruent.